Hello everyone, welcome back to my YouTube channel and my name is Hardeep. This is video for some of my advanced users who are interested in learning Kubernetes, and I rearranged my repo. If you go on the GitHub slash the Kubernetes show, inside that you'll find two repositories. One is for Kubernetes, another is for Linux. So if you are new here, welcome. I would recommend going through these first three videos and then continuing to this CKA certified exam. And in this one, what I'm trying to do here is uh, align my course with the course outline, what is mentioned in the CKA curriculum 1.32. You'll see some concepts that I have already covered, and I have my cluster already running. If I say k get nodes, you can see I have three nodes. One is control plane, two are worker nodes. And today we will look at pods, what pods are, uh, what the anatomy of a pod is, lifecycle management, and a little bit more. The third video link, it'll be this one. Once I am done uh, recording it, I'll be uploading it. So now, first, let's understand why I am so interested in showing you pods. Pods are the smallest unit of deployment in a Kubernetes cluster. When I say smallest, it doesn't mean that there is nothing smaller than pods, but those things are contained within the pod. So a pod is a kind of logical boundary that helps to run your containers. So if you have one pod, it generally should run one container. That is the kind of a best practice, but we will see there are deployment styles where you can have more than one container inside a pod. Now, you can run these containers using two ways. One is imperative way, another is declarative way, right? So both have its pros and cons. Imperative way, you don't need to remember the commands. kubectl run helps you to create the basically deployment file or even run the container, right? So what I'm going to do here is just copy. Let's, before I do that, kget po is short form for pods. So I can do kget pods or I can do kget pod. All three are the same thing. And here I'm running this command. What I'm saying is kubectl run. This is the name of the pod and this is the image that it should run. I'm saying don't ever restart it, and then uh, I'm specifying a command. That command runs, and you'll see. Okay, so I just ran it. Something happened, but I don't see anything. Right. So how do I see the content or what happened? First, let's see the pod. Right. So if I say kget pod, I don't even need to write the name of it, but if I do, you can see it says completed and this 0 of 1. So basically what I requested is I should have one pod running, and right now there is 0 running, right? Why? Because I gave a command, and that command was echo, and basically it printed something on screen and then it disappeared, right? So what I could do is k get, so I can do k logs, and like this you can see this is the command that I ran k get pods, or I ran a command k run hello, and inside that this was the command line argument, and you can see the output from that pod, right? So this is one way of running the pods. Now you'll have to kind of keep cleaning. You don't want your resources to be kind of consumed by pods that are not needed. This is something you should learn when you are deleting a pod. It takes some time because there are some finalizers that take time to go clean up all the resources. So sometimes if you are in the time crunch, for example, during the exam, you don't want to wait, right? So you can say wait zero, you can say force also, right? So there are some options that you can use, but I don't want to because I don't have too many things going on. I can run command and you can see the pod is gone. But if I run the same command again, you can see it says no resources found in default namespace. Now look at the next command that I have here. It is same thing, but I'm passing some command line arguments. I'm running a command, and that command is printenv. It is printing the host name and port, Kubernetes port, right? It's equivalent to doing echo dollar host name and dollar Kubernetes port, right? If I run it, you can see it did something similar what we saw happen earlier. This one also would be in the same state. If we try to look at it, it says zero running, one completed, right? One was expected, but state is completed. So you can do k get, or you can do k describe pod, uh, not completed, k describe pod, name of the pod, right? So you can kind of see what the output is. You can see it was completed successfully. It was a busy box container. You can see state is terminated because it completed. The command completed successfully. That's why exit count is zero. It has not restarted, and we can see that's why it is set to zero, right? So similar thing, in the last video we saw some events also. Again, if you are during the exam trying to troubleshoot, you can do k get events, and if you do this, then you are seeing only events. Right now it is showing events for previous part and this one, but if you want to see for a particular thing, then you can do for pods, right? So events, k get events for, I think we can do pod and the name of the pod. I think this one we named as Argo demo. uh, Events, k events for parts Argo demo. Now you can see it is showing for that particular part, rather than what I did earlier. It was showing for the hello part too, which we couldn't see here earlier, right? Because I ran it and I deleted it, right? Even though pod was gone, the events were still there. And that's when I did this k get events, you can see it is showing events for Argo demo, and it was also showing events for hello pod. This is why last time when I recorded the video, I mentioned you should try to focus your command to a particular pod or deployment, whatever you are looking for. This one is a better method. Running kget events without hyphen hyphen for is almost like doing a cat on 10 GB file. You don't want to do that. You want to get only specific things. Maybe grep is a better option, right? So this is something similar. You are doing grep maybe for only for the given type of Kubernetes component. Here it is Argo pod. Again, it's just the name. And now we are looking, because this command, when I ran, I said printenv hostname and then give me the Kubernetes port, right? So these are two environments inside that container, and it is running printenv. That's why we see the values here. So what I did, I ran kubectl logs and provided the name of the pod, and I have the output, right? Nothing fancy, nothing special. This is how you kind of get some data out of pods. Now, if I say you can, rather than running like this, you can create a uh, you can create a YAML file that you can use. You know, uh, let's see. If I run this command, it's not going to produce YAML file. Instead, it'll create a pod. I don't want that. You see, what I'm trying to do is hyphen hyphen dry run client hyphen o YAML, right? But if I run it, what did it do? It created a pod. It was not the intention. Why did it happen? Right? I have mentioned here also, right? So why did it happen? It happened because after hyphen hyphen command, and once you pass this double hyphen, anything after that it treats as kind of argument, right? So let's see what did it do. First, let's look at the pod status, right? We ran a command and it shows something similar. One pod was expected running, but only zero are there because the pod completed. Again, it was just a single command inside. It should have shown echo hi there, and that's it, right? Now let's try to get logs. Instead of showing hi there, it is showing hi there and this remainder thing too, right? So what happened? After command and this hyphen hyphen, anything listed after this is treated as a kind of command line option, right? Or an argument that should go inside the container, right? So how do we kind of not do this and actually saw the output which we intended earlier, right? So let's delete this pod and redo it, recreate a pod. Now I have given commands here. All you have to do is copy paste, but rather than copy pasting, try to understand what it is trying to do in the back end. Now this was the intention when I was talking about this generating YAML file for review, right? During the exam, you'll have to write several YAML files. So being able to create these YAML files with speed is very important. Time is the essence. You should be able to create these YAML files without landing into errors or creating problems for yourself where you're troubleshooting, tab spaces, this, that, right? So intention was when I ran this command here, which didn't work correctly, intention was to produce a YAML file. But instead of doing that, it created something which was not intended. Difference in this command is I am saying dry run and o YAML before uh, I say hyphen hyphen command. You can see the difference here. Here it was command earlier and dry run o YAML later, but here dry run client o YAML, o is output. I'm saying print in out YAML format and then running command, right? So it produces a file, but if I say kget pod, or there is no pod created. Why? Because I did dry run client. Client means do it on my client machine rather than trying to run it on server side, go validate, and then show me the output. That's why it is client. What is the fun of doing this, right? So you can quickly create your files, review them, or you can send them, for example, to a file, right? Let's say temp test dot YAML, and then you can do cat temp dot test dot YAML, right? So during the exam, I would recommend giving them numbers. So if you are on, let's say, third question in the exam, you would say, some description like you have a requirement to create a pod with two containers, right? You cannot do that on the fly or with imperative commands. You'll have to go declarative, right? So to do that, you'll have to write this file. So I would say name your file as question three two containers dot YAML, something like that, something that you can very easily go back to reference if you need to. But okay, this is the file. Now I kind of alluded towards it that you need to run two containers, right? By default, with the imperative commands, you are able to run only one container. Another problem with this is whatever name you are specifying for your pod, you can see here I'm saying custom CMD, right? That's the name of the pod. But inside that, if you see containers, this is first container from there to here, right? Because of this tab space you can see, right? So this also gets named as custom CMD. In exam, you'll have questions where you'll be asked to provide a different name. For example, you'll be asked to name it something test container, right? So like this. So K apply hyphen F tmp test.yaml k get pod. You can see it says container creating, right? Now it's completed. Now how do I see if it actually named what I gave it? So k describe pod and custom CMD. If I scroll little up, you can see some of the details. It is showing you the label. This is the name of the pod, right? And then somewhere here, you will see containers. If I am looking right, I should be able to see. So it says command terminated environment. Um, what did I name? I named it test container, right? That is what we named it. Grep test container in tmp test.yaml, right? You can see that's the name I provided it. And if inside this I do grep test container, you can see it created a test container inside that pod. So if you have a requirement where you need to give a different name to container, you cannot do it using imperative commands. You'll have to go declarative. But that's where imperative command comes handy, because it will let you write a Kubernetes manifest, and then you can go extend it, enhance it, modify it as you need, right? So this is just one way of doing things, right? During the exam time is the essence, as I said earlier. So I would recommend getting your hands on how to create these files imperatively, then modifying them, adding require kind of attributes that you need, right? So anyways, k get k logs. Let's see, did it run? Yes, it did. K delete pod, and my pod is custom CMD, right? Now declarative method I already talked about. This is what I was showing you earlier also, right? So but let's run it again. I ran another one. It's named as command demo. You can see I'm asking it to run a Debian. I'm saying restart on failure only. If something happens, then only restart. Then running a command host name, Kubernetes port, and a demo.yaml, right? This is the kind of output that it generated. It didn't create any pod because I had dry run listed in there, right? So you'll see something like this. Now you have chance to go modify the things as you need, right? So another thing I wanted to highlight on the pods, generally, pod, we are running printian we here with two arguments. That's what it is kind of trying to explain. Possible values for restart policy. You see, when I ran this command, I said restart on failure, right? And you can see here, this is where that thing came in our manifest file. Now restart policy could be always on failure or never, right? So now how does restart policy work? Before I get into restart policy, I wanted to talk about something called init containers. There is sidecar container. So there are different type of containers you should understand. During the exam, there'll be one question at least where you will be told to implement init containers, right? What are the init containers? Init containers are something that is run before your production or actual container runs. what kind of container they could be. For example, you are trying to run a uh, let's say web server, but before your web server runs, you want to download something from somewhere, run some custom commands to modify things. Or if you have a database, you want to basically download maybe from S3, the export, and then import it. So you can do all kind of crazy things in your init containers. Init containers to help with to basically run your main container. That's what it is, right? So as I said earlier, a pod can have multiple containers. So in these tests which I was running, we are running only one container, but we can have multiple, right? So there is one init container. Init container always run to complete. When I say always run to complete, that means whatever we were running here, these commands or these containers, they were kind of init containers. Why? Because they were running a single command. For example, this hi there, right? Command ran, it completed. So when we saw the output, when we did get pods, right, we saw it as completed. You can see here the state completed. This is exactly what init containers do. They do a specific task. Like I was saying, they download something from maybe S3, right? Downloaded a, SQL dump, then that dump gets loaded into database and then it completes, right? That could be one example of it. Copying some file from somewhere to something to ensure your, let's say, web server runs properly. That could be another thing. So init container always runs to completion, right? That's one thing to remember. You can have more than one init container. Like I'll show you one example, a very interesting one. If you have deployed Kubernetes using my script that I have, watch the first or second video. You'll know more about it. What I mean by that, right? So let's see, get ns. So I'm looking at namespaces, but there is a namespace in Cube system. I have Cilium deployed, I think. K hyphen n cube system get parts, and yes, I have Cilium deployed. And uh, let's see, describe parts. So let's look at one Cilium pod, and if I say grep hyphen I image, you can see it is showing so many images. Why? Because there are multiple containers inside it. Okay, so any Cilium deployment, if you kind of look at it, explore it, you can do, instead of describe, you can do get pod and name of the pod hyphen o YAML. You'll see output in a YAML format. But now if you want to see like how those containers look like inside the deployment or the YAML file, you can very well go and look at this one. This will give you kind of very good details into how you run multiple init containers, right? So that is where I was going. You can have more than one init container before your service could launch successfully, right? And uh, with that, I'll get back to what I was showing here. Your policy applies to all init containers within the pod, right? So you have the you have mentioned your restart policy as, let's say, on failure, right? It will go and restart all your init containers within the pod if it need to restart, right? And then next is sidecar containers. These are used for maybe logging, right? Or you have a container that could help you to encrypt your traffic. For example, we were looking at Cilium. It has something called Envoy. uh, you can run Envoy proxies to offload your certificates SSL, right? So that could be another option. uh, if you go into documentation, in my previous video also I mentioned you should be very familiar with this documentation, how to go find the right information when you are having that time crunch and you are during the exam, right? So you can see here a container shown and two init containers shown here, right? Then what I was talking about is sidecar, ephemeral container, right? All this very interesting information. I would highly recommend going and spending some time reading through these, understanding these, getting your hands dirty with these, right? So again, coming back to what I meant by, on failure is, I have kind of provided details here, right? So when a container restart, Kubernetes used exponential backup strategy. Yes, this is very important. If your container fails, Kubernetes is slowly adding more and more time to it. It is called back off strategy. So how does that help? You don't want too many failures or too many pods keep trying and hitting your API server. That could cause API server slowdown. Basically, in the end, if you have a failure at large scale, that might kind of uh, turn your own deployment into denial of service attack, right? So what happens? Your pod failed. For example, it's not able to fetch a image from uh, container registry. First, it'll wait for 10 seconds. Next iteration will be 20, then 40, 80, right? It goes all the way to 5 minutes, right? So this is to avoid rapid restarts, right? So I have given some more information. I would say read through this, right? uh, Again, we have seen how we are running simple commands, right? You can define with your hand a pod definition, or you can run imperative commands. I've kind of provided a quick table of summary. uh, what are the benefits of imperative and declarative? uh, so imperative, you are during the exam having time crunch, you don't want to make a mistake. You run imperative commands, kubectl run and do hyphen hyphen dry run client, right? Oh, YAML, very easy. But problem with this is you are making changes to your cluster on the fly and there is no version history, right? So a big problem if you are doing it in a enterprise environment. Now let's think about declarative. You are writing files. Those files could be checked in into GitHub. Your teams could kind of collaborate with each other. Then it helps to keep the version control also. If you have thousands of these files and you are trying to do things in declarative way, there are limitations. For example, declarative way says you should have everything inside the GitHub. But what if you have secrets? You have username, password. You don't want that to be checked into GitHub. So there are ways to solve that too. There are sealed secrets and all. We'll talk about that when we get into those advanced topics. But it is those topics are not part of this course, but still we'll be covering them at a later stage. Yeah, I have kind of given some tips, provided you that after a CMD flag you should not add things. It maps to hyphen hyphen command maps to the entry point. In Docker there is a kind of a statement which is named as entry point, right? So in entry point basically it is what container will start with, and then you are providing arguments, right? So when you do hyphen hyphen command, it is actually calling for the entry point. And you can see the logs. And then how do you visualize your pod? How does it look like when you deploy a pod? So I have tried to give you a Marvin diagram. So you click on this page and you can kind of see these diagrams. And same thing, the output of that I have shown here. You have two containers in a pod. Pod is a kind of virtual boundary. Inside that there are two containers. These containers, whatever is inside this pod, they share the same volume. You can see this pod is also using the shared volume container 2, also using. If I have 10 containers, which is against the uh, you know Kubernetes standards, I would say, right? You should have one pod, one container per pod. Let's assume you have 10 containers inside pod. All will have access to the shared volume. Similar story, if your network interface is attached to a pod, not to a container. So whatever IP you have, they are all using it. Uh, okay, so if you have pods running on two nodes, there is a node A. You can see here it is listed as node A, and here is uh, node V, right? So how does it talk to each other? It talks to each other with the help of CNI, container network interface, and you have kubeproxy that helps you to transfer the traffic from one node to another. We'll be diving deeper into all this, but this is something I wanted to show you, that when you have a container, that container is not kind of a standalone thingy. It has um, some storage also, some shared network also. It has namespaces. We'll talk about all that uh, possibly in coming lectures, right? So I'll go back to the course, and I'll show you. If you are uh, eager to learn what is namespace, resource isolation, how does it work, I have already created a GitHub link for it. Video I'll be recording for it later, but for now I think you would understand what a container is, and how do you create it, how do you delete it, how do you create it imperatively versus declaratively, right? So when you run a container, uh, how do you see what happened? Is it running? Is it completed? Is it stopped? Is it having an error? How do you pass command line argument? So that was the intention of this video. It is to kind of get started with pods. Next week we'll be getting into replica set deployment namespace. I'll try to cover more than one topic because we have many of these. uh, I want to uh, kind of make sure you are getting the content at the right speed that you could consume. But for now, if you want to kind of learn more about pods, I have provided some links. For example, inside this, there were some links for init containers and sidecars. So your homework is to read through these, learn about these. The pod life cycle, you should learn the pod life cycle, right? What happens when you fire a command to create a container, right? You fired a command, you said kubectl create or kubectl run, right? What happened? Your command goes to the api server looks at it, and if everything looks correct, it goes, it talks to the scheduler looks at available nodes, and then accordingly it says, okay, I'll run it on this particular node. On that particular node, scheduler also has information about what is node health looks like. Does it have enough resources to run the container? Does it have enough CPU memory and all that, right? So once the container is scheduled to that node, on that node you have kubelet running. Kubelet will talk to CNI, it will talk to CSI, it will basically container, it will talk to the container runtime, it will create container for you, it will use your CNI to give it a IP address to, it will use kubeproxy to kind of make it talk to the other places, right? But that is kind of behind the scene. Then there is a controller manager who is always checking the health of it, whether it should be running, it is running or not running, what state it is in. So all those components are kind of doing things in the background, right? So what happens when you schedule, you you ran a command, it goes into pending state. right? Once it is in pending state, it is trying to figure out where should I go, where should I run. I was talking about scheduling, right? So this is what is happening. It is downloading container image. Once container image is downloaded, everything is validated. It says running. A pod is bound to node. Bound to node means one node has a IP address assigned. If it needs a volume, storage volume, that is created, right? Everything is done, and you have a container running. It could be a succeeded state, right? Every inside the pod, you had few things that should be executed, and those executions completed, it is in succeeded state, right? It will not be restarted. Pod have terminated in success and will not be restarted. So you have defined it in a way that you don't want it to restart, right? What I was showing in my outputs or commands, those were the statuses when it was showing succeeded, because when we did describe, it was showing succeeded there, right? Otherwise it was showing completed in the get parts output. Failed could be it is not able to download the image, you don't have enough nodes. In those cases generally it stays in pending, but still you have some issues. In those cases it will be in failed state. Then for some reason there is no connection to the pod, it's not able to get the state of it, it will go into uh, unknown state, right? I would say read through this documentation is the best available out there. You should understand each uh, kind of life cycle stage of the container. You should understand, how does problem get handled. For example, I was talking about that uh, exponential backup, for example. Here we are talking about that. So all this information is necessary for you to successfully pass the exam. If you don't understand these basic constructs, it'll become difficult for you to pass the exam. There is a way to pass the exam, but it won't help you in real life. So I would say go spend some time, learn from the documentation, read through it. One last tip that I want to give you, right? So you want to know where a particular reference will go, right? For example, you want to specify your pod should run on a particular node, right? So how do you find help for it, right? One way is you go and search here, right? Another way is you can say cube uh, explain pod, let's say, right? Now let me make it full screen. So if you say cube explain pod, it gives you something. But if you say recursive, now it is printing everything. This is kind of full parameters that you could specify. There are so many of them. If I say WCL, how many? 1300 you can specify, right? But I don't need all this. I want to, let's say, pod dot metadata, right? I want to learn more about metadata. What all kind of sub attributes I can specify. You can see you have full help available here. You want to, let's say, spec. Inside spec, you have all these options available. And then in spec, I want to understand topology spread constraints. Remember, I was talking about assigning to a particular node or something, right? You can do all that. But you need to understand how to read this, how to read the output of it, right? So this is kind of an array. Inside that there'll be more than one values available. So if I say volumes, it means you can have more than one volume, right? That's why it says volumes. Some are kind of very descriptive, you can easily read, but understanding the output and understanding this bracket, what does it mean, could make your life much more easier. With that, I'll be closing this. Thank you. Take care. I would say read and let's meet next week. Take care. Goodbye.